We return to this simplified tree of human evolution, and here we're going to take a look at Homo neanderthalensis, the Neanderthals, and we'll consider their relationship to Homo sapiens, also sometimes referred to as anatomically modern humans. And in terms of a comparison between the two, on the top we have a skull belonging to Cro-Magnon man, so that's Homo sapiens. Below we have a skull belonging to a Neanderthal. And you can see that there are differences. Immediately you can probably pick out the heavier brow ridge development in the Neanderthals. And also if you take a look at the skulls in side view, there are big differences. If I highlight here the profile of a Homo sapiens skull, and then we'll do a similar profile on the Neanderthal skull, and you can see in the Homo sapiens skull we have an elevated forehead area, so go straight up and then we run across the back. With regards the Neanderthals, the forehead is very much swept back, and in fact we have a larger area at the back of the skull. That's termed the occipital bun. So in terms of the profile and shape, they're quite different. It's also been noted that in the Neanderthals, if you imagine where their eyes would have gone in those eye orbits, those eye sockets, their eyeballs would actually have been slightly forward from the front of their brain. And that's actually completely different to the arrangement that we see in Homo sapiens, that we see in ourselves today. It's often been thought that Neanderthals were in some way a more primitive version of ourselves, and that they came before us in time, and then that we ultimately developed or evolved from them. Now that is actually quite incorrect. If we look at the evidence, we'll see that the first Neanderthals appear around maybe 400,000 years, maybe around 180,000 years before present. If we look to Homo sapiens, anatomically modern humans, we see the earliest forms appearing in Africa around 200,000 years ago, and maybe as old as 300,000 years ago. So you can see there's actually plenty of overlap. There's potential here for these two groups to have appeared very, very broadly simultaneously. When we think about Neanderthals, we generally imagine them as a stocky hominin form, perhaps cold adapted and specialists, what we would call stenobiomic. And this sort of compact body is something which we see today in humans who live in colder parts of the world. And by contrast, with regards Homo sapiens and anatomically modern humans, they appear to have been more technologically and culturally advanced. So the tools which they use were more sophisticated. We see evidence of symbolism, painting, cave paintings, things like that, and all of this was traditionally associated with Homo sapiens. And the interpretation there would be that anatomically modern humans were more eurybiomic, so that means they are more generalist. They're not stenobiomic, which is evolved towards a specific environment. Homo sapiens are more flexible in the range of environments that they can inhabit. Now those two ideas, the stocky, cold adapted specialists versus the more technologically and culturally advanced, those two sort of end members are being challenged. So we've a suggestion now that Neanderthals may actually have produced cave art. And additionally, the idea that Neanderthals were adapted for the cold, that's been challenged. And one way of thinking about it is that during their time range, and they were a very successful species, they lived through cold intervals, yes, but they also lived through much warmer interglacial periods, and they were very successful during both. So that might actually be a slight oversimplification. We wonder if Neanderthals had speech. And obviously this would be important because it would tell us something a little bit more about Neanderthal community and Neanderthal society. We know from a fossil find in Israel, in a place called Kibara, a Neanderthal skeleton was found with a very delicate bone that normally is not found preserved. You see it, it's in the throat. It's called a hyoid bone. And its job, it's a free-floating bone, and its job is to support the voice box. And actually, the Neanderthal hyoid bone recovered from Kibara suggested that this was adapted for a voice box. But additionally, we know that Neanderthals had a particular gene called FOXP2. We have that gene, and that particular gene is associated with the ability for language. So it is possible that Neanderthals had some speech, had some ability to communicate with each other. Another thing which we see with the Neanderthals is that they appear to have buried their dead. We're not sure why they chose to do this. Why did they intentionally place their dead into the ground? Was it because of some ritual symbolic significance? And with that I hasten, to use the word religious significance, but was there something along those lines, a symbolism or something, returning a member of the community back to the earth? Or was it just purely practical, a sort of, just bury the dead, get it out of the way, because it could be unhygienic, something like that. The practical knock-on effect of that is that it means for the Neanderthals, for the first time really, when we think about all of the various human hominin taxa that we've examined thus far, we actually have a pretty good fossil record for Neanderthals. And that's linked back to the fact that they did engage in this burial practice. If we think about brains, and what we see on screen here is a modern human brain inside a anatomically modern human cranium. And if we then compare that with a Neanderthal, we've already looked at the skull and the difference in shape of the skull, and it's perhaps no surprise that we see differences in shape of the brains. Now, it's important to note that there's a similar volume in terms of brain size estimated between Neanderthals and anatomically modern humans. In fact, some estimates suggest that Neanderthals may even have had a slightly larger brain than modern humans. But significantly, if you look at the Neanderthal brain, it is quite different in shape, has a more elongated and less bulbous globular shape. And looking at endocasts, we can tell that based on shape, Neanderthal and modern human brains may have functioned or operated in slightly different ways. For example, with the Neanderthal brain, the occipital lobe is much larger. And when that is linked to the observation that Neanderthals themselves had much bigger eye orbits, they appear to have had much bigger eyes, then the sense is that Neanderthals may have had better vision. On the other side of the equation, with regards anatomically modern humans, we see that in the early Homo sapien specimens, they had a larger cerebellum than their Neanderthal counterparts. And this area of the brain is very important in modern humans for motor skills, higher cognition, learning, reasoning, social skills, etc. So we think that the brains may have functioned in slightly different ways, may have even perceived the world in slightly differing ways. This is a map of what has been termed the Neanderthal world. And you can see that Neanderthals were a Eurasian hominin species. So all the little black dots that you can see there, ranging from in the Iberian Peninsula around Gibraltar through France, and Germany. The Neander Valley is where the first Neanderthal was described, all the way across through the Caucasus and even further afield. That is the boundary of the known Neanderthal world. And you can see at this reconstruction, during the Pleistocene, we have the limits of the late Pleistocene glacial maximum and then the middle Pleistocene glacial maximum. So this was a world which was fringed to the north, limited perhaps to the north by the advancing and then retreating ice sheets. And we know actually that their range is much further now than is indicated on this particular map. So this bit here needs to be extended, and extended considerably further. We have Neanderthal finds now reported further east into Uzbekistan and also in the Altai mountain area of southern Russia. And it's really interesting to think that this was the range, this was the world where Neanderthals lived. And at the same time, we see the evolution, the development of Homo sapiens, anatomically modern humans, in Africa. Here we have a comparison between the skeletons of Homo neanderthalensis and Homo sapiens. And at a first pass, they look broadly similar. But actually, when examined in detail, there are differences observable in practically all of the bones of the head and the body. For example, you can tell in a Neanderthal skull there are differences with regards to teeth. So Neanderthal teeth had a much larger pulp cavity than anatomically modern humans. In general, looking at the skeleton, the postcranial skeleton of Neanderthals, they had a robust, stocky and compact body, generally 12 to 14 centimeters shorter than we are today, weighing in somewhere between 65 and 75 kilograms. They had very, very powerful limbs, and we know from examining their bones, their limb bones, that very strong muscle attachments, and their chests, they had barrel chests, and really they were quite powerful humans. We also see on the Neanderthals evidence of lots of bone trauma, so fractures and breaks, some of them which heal. So these would not have been fatal breaks by any means, but they do indicate that Neanderthals lived a challenging lifestyle. We think that Neanderthals may have been apex predators. They look to have been very skilled hunters, capable of taking down quite large game, and we can see in the background here a herd of mammoths. They were also not averse to scavenging for food, and we've evidence from sites such as in Gibraltar that they also consumed seafood. So we've evidence of them eating shellfish and also butchering dead seal carcasses. The Neanderthals lived through glacial periods, so the fact that meat featured so prominently on the Neanderthal menu comes as no real surprise, because today, when we look in places in the world where people are living and it's very, very cold, meat is a very, very important part of the diet. And that's simply because of the fact that vegetable and plant materials are relatively rare, thin on the ground. Neanderthals are known to have used fire, and they used fire for cooking. They presumably used fire for keeping warm and for warning off dangerous animals. They also were responsible for a particular type of stone tool technology, what's referred to as Mousterian tools or Levallois technology. And with regards Mousterian tools, they're very, very characteristic, and they're a massive improvement on the previous stone tool technologies. What happens is you prepare a core stone and you knock an edge off the core stone, and that edge becomes a razor sharp flake. And you can see some examples of flakes on screen here, and those flakes then would be hafted on. They'd be used either for scraping, or they could be hafted onto poles or sticks to be used as spears. And with regard to Mousterian tools, we're getting sharper, more effective stone tools. We're also able to make much more stone tools from the same amount of starting raw material. And interesting also, this is much more sophisticated than the manufacture of stone tools which had come before. And this is something which Neanderthals used over all of the time that they lived on Earth. So clearly the knowledge about making Mousterian or Levallois tools was passed on from generation to generation. And maybe it was passed on simply through observation, but equally it may be the case that language, speech, communication was an important part of passing down these vital skills for manufacturing these stone tools. And with regards to stone tools, it's really interesting that Neanderthals don't appear to have made projectile weaponry. So we don't see evidence for bows and arrows. We don't see evidence, for example, a spear thrower, which you'd attach then to use to throw a spear an even longer distance. Now it may be that Neanderthals did have projectile weaponry, but they just didn't make them with stone tipped implements, and that those wooden arrows or wooden throwing spears, that they just haven't survived. You know, we haven't picked them up in the archaeological record. But generally we just don't get a sense that they had projectile weaponry. They appear to have preferred to go in for very stout, strong thrusting spears, which you can see the Neanderthals in the image here holding. And that means that when it came time for hunting, they actually had to get very, very close and personal with their prey that they were trying to take down. So a very dangerous lifestyle. Having said that, we have evidence, such as a site in Jersey, in the island of Jersey, and there we have evidence that a team of Neanderthals cooperated, and they drove a herd of mammoths over a cliff edge at the coast, and then went down to finish off, to kill the mammoths and butcher them at the foot of the cliff. So that clearly tells us that Neanderthals were working in teams. And again, if that's what they're doing, they must have had the ability to communicate well with each other. So the question still remains how we classify Neanderthals. And there are two schools of thought. One is that we should consider them a separate species to ourselves. So the name would be Homo neanderthalensis. The opposing idea is that no, they're more or less the same as Homo sapiens, just a subspecies. So the term there would be Homo sapiens neanderthalensis. And this flows back into our ideas about how precisely Neanderthals were related to ourselves. Because if we go with the classification at the specific level of Homo neanderthalensis, the reasoning for that is that Neanderthals are morphologically really quite distinct from anatomically modern humans. And you can see those differences in every bone of their body. But if we assign them to a sub-specific designation, Homo sapiens neanderthalensis, the suggestion there is that maybe there is some capacity for interbreeding. The fact that we're not looking at reproductively isolated populations. In terms of trying to understand where the Neanderthals came from, how they got into Europe, and what precisely is their evolutionary relationship to Homo sapiens, to anatomically modern humans, there are two main contrasting theories. The first is termed the multi-regional theory. And the multi-regional theory suggests that we have an initial wave of dispersal. So we see Homo erectus initially migrating out from Africa about 1.8 million years ago. And those groups of Homo erectus, they made it out of Africa into Europe and also into Asia. And as we move and look up the screen, we're moving towards the present. And at the present day, we reach anatomically modern humans. And you can see on this scheme, the Neanderthals in Europe essentially represent a continuation, a continuum. So they feed, or they become, essentially contribute to the modern human populations which we have in Europe today. The dashed grey lines that you can see all the way up, that represents interchange, genetic mixing, all through this interval of human evolution. The rival idea is one which is termed out of Africa, or the recent single African origin model. And it begins initially in a similar fashion to the multi-regional model, in that we see Homo erectus dispersing out of Africa around 1.8 million years. But what you'll notice is there's no dashed grey lines. So there's little to no genetic interchange amongst all of these dispersed populations around the world. Now, crucially, in the out of Africa model, we see at around 100,000 years ago, what we see is a second wave of migration out of Africa. And importantly, we see the evolution of Homo sapiens initially in Africa. So those African populations, in a second wave of migration, move out of Africa into Europe and into Asia, giving us the anatomically modern humans that we observe there today. And significantly, you'll see that on the scheme, the Neanderthals are shown essentially as a dead end. They don't contribute to the genetic makeup of the populations in Europe. This particular paper, published in May 2010 in Science, fundamentally changed our opinion of who the Neanderthals were and what precisely their relationship to us was. It's entitled The Neanderthal Genome, and it was published by a team led by Svante Pääbo from the Max Planck Institute in Germany. And amazingly, what they did, and what you can see on screen here, are 3 fragments of Neanderthal bone from Croatia. And they were able to extract the ancient fossilized DNA of Neanderthals from this really quite unassuming, rather scruffy fossil material. And based on that, they were able to tell us the genetic makeup of Neanderthals. This really was the beginning of a revolution in our understanding of the Neanderthals. I spoke to Svante about this a couple of years ago, and actually I can reveal that he believed that the reason these 3 particular fossil bones were so rich in ancient DNA, ancient Neanderthal DNA, is that they had been intentionally smashed for marrow extraction. So they had been cannibalized. And in particular, other Neanderthals had put these bones in their mouth to suck off the marrow, and the saliva they left behind put lots and lots of Neanderthal DNA onto these bone fragments. 2010 publication by the Svante Pääbo team revealed to us for the first time the secrets of the Neanderthal genome. And perhaps one of the most surprising findings of the study was the fact that traces of the Neanderthal genome were still present in the genes of living modern-day Homo sapiens today. And specifically, we see evidence of Neanderthal ancestry in populations outside of Africa. And the reason for this is that it's believed that when early Homo sapiens arose in Africa and then began to migrate out of Africa. When they came into Eurasia, they encountered Neanderthals, and evidently they must have interbred with the Neanderthals. And in order for those genes to mix and for the Neanderthal genes then to be passed on to modern human populations, the offspring from that interbreeding must have been viable, must have been fertile. So that was really quite remarkable. And essentially all humans living outside of Africa today, with their origins outside of Africa, have somewhere between 1 and 3% of a contribution to their genome from a distant Neanderthal ancestor. This find was reported in 2014, and really quite remarkably, a series of fossil human footprints were discovered in sands at a location called Happisburgh, which is close to Norfolk in England. And these footprints were dated at around 800,000 years old, maybe as old as 850,000 years old. And this location is really very, very significant. And it challenges a lot of our previous ideas and notions about the nature of human migration and dispersal. Because these footprints in Norfolk represent the oldest hominin footprints outside of Africa. That age, 800,000 years, is staggeringly old. If we think about it, the spectacular Happisburgh footprints tell us that we have a human presence in Britain at around 800,000 years. And that really is quite a turn up. It gives us a clear indication of the speed with which the early human ancestors migrated across Europe. The date is significant. That's far too old for a Neanderthal to have made those footprints, far too old for Homo sapiens. So we have to look to earlier hominin forms, maybe something equivalent to Homo erectus, or maybe something a little bit derived from a Homo erectus. If we look in Ireland, the first evidence of human occupation that we have is much younger. It's only 12,500 years, and that is actually based on cut marks on a bear bone which was recovered from a cave in Clare. There's a big gap there, and I think that this is really just a sampling artifact. I think the evidence for an older human presence, human occupation in Ireland, has yet to be discovered. And so we come to the end of our journey in History of Life, and over the past 6 weeks, the past 6 themes, we've covered a remarkable amount of that history. We've explored the evolution, the development of the first life on Earth, the evolution of more complex animals, diversification in the sea, diversification on land, and then finally we arrive today in this lecture with the emergence of our own group, the anatomically modern humans. And I'd like to finish really where we began and come back to this quote from Charles Darwin in On the Origin of Species. And I read this out at the beginning of the module. I'll read it again at the end here. There is grandeur in this view of life, with its several powers having been originally breathed into a few forms or into one, and that, whilst this planet has gone cycling on according to the fixed law of gravity, from so simple a beginning, endless forms most beautiful and most wonderful have been and are being evolved. I do really hope you've enjoyed the module and felt that you've learnt something valuable. And I hope that in the years ahead you can take some of those lessons learned from that epic journey, the evolution of life on Earth. Take that and keep it with you.